Hey everybody, and welcome back to another fun and exciting pre-calculus class. Today we're going to be jumping into chapter number 12 in your book. You might be looking at the background and looking at me and going, what's going on? Chapter 11, chapter 12, everything has changed. Well, you're right. So we did some construction, and I kind of took some time off, and, here I am. Things are different, but still me teaching the same information. So good to see you back. I know for you it's been like one day. For me, it's been like 1 year. So, chapter number 12 in your book, we are on page 220. All right, page 228 talks about the conic section. What is the conic section? Well, the conic section is, another word for conic is the cone. Okay, so this is of the cone. So the shape of the cone. So if you're looking down there in your book, you have some shapes here underneath the cone. And it kind of tells you and shows you different pieces to that. We'll talk about this in just a second. But the geometrical shape, the cone, that's what we're dealing with here in this section. So we'll be doing the introduction in this lesson. We're actually going to do 12.1 and 12.2 in this video, and then we'll do some other videos on the rest of the information here. Let's jump back over here to my computer screen and let's talk about the standard form of the cone. Here it is. It's ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Now you're like, whoa, what is going on right there? It's kind of like a parabola with ax squared plus bx plus c equals 0. So that's a standard form of a parabola. This is just more information, right? This is just more things doing different. See, with a cone, you have things going like this. You have circles. You have all kinds of different, kind of shapes in that cone. So there's got to be a lot of stuff going on here in your mathematical formula. And if you look at this, you can see pieces of this that you know what it is. So if we took ax squared and we took plus dx and we took plus f, so if we took everything else off, right, that is just a parabola. So in other words, if you take pieces of this formula, you can find different shapes within the formula. But this is the standard form. What are all these letters right here? All these letters right here are just constants. So those are going to be 3's and 2's and 7's and things like that. The other ones are the variables. And if you remember, the x is going to be, right, it's on the x, it's on the left and right, okay? And then the y's are going to be your up and downs. So if you have x's and y's in the same equation, you're going to have different things going on your graph. So there's the standard form. We don't deal with the standard form like almost ever in the whole format. So we don't take the whole thing at the same time. So here are some parts of the cone. All right, so we have a circle. And if you'll look in your book, I'll kind of toggle back and forth between the two. So this right here is the circle part of the cone, of the conic. This is the circle conic section, okay? Here's the ellipse. Here's the parabola, and here's the hyperbola. We can see the parts of the cone, the circle, the ellipse, the parabola, the hyperbola. These are the first four are the ones that we're going to be talking about in this section, in this chapter. We've already talked about straight lines. We know what straight lines are, right? We've already dealt with that. Points, we already know what a point is. And then no real curve means that it could be like using imaginary numbers and things like that. So it's like a curve, but it's not a real curve. And so we won't get into that either really in this section. So the number 5, I just kind of put those all together. The straight line, the point, and the no real curve. We're not going to really talk about those very much. This is where we're going to focus our time. The circle, the ellipse, the parabola, and the hyperbola. All right, so let's keep going. Look down here, and I just kind of wrote this down. The word conic section is what's called the family of curves created by a cone. So when you have a cone, when you put the cone on the graph, you're going to have little sections that you can kind of take out, and you can look and you can say, okay, there's a circle. Okay, there is a hyperbola. And you're like, what is a hyperbola? Well, we'll get to that. We'll talk about that in just a little bit. So let's switch back over here to the book real quick. You can turn the page and let's jump into chapter 12, lesson 2, the equation of the circle. So it says, though the circle is a conic section, its equation is most easily derived from the distance formula. Now, what you'll see is that these two things are going to overlap. So when you use the distance formula, it's going to give you a standard form of the circle. But that standard form of the circle does fit into the standard form of the conic section, which we already talked about. So here it is. When you use distance with being the radius, so that's the r, and then the center is K and H. So what does that mean? H and K. Well, H is going to be your X point and K is going to be your Y point. This is just the center of the circle. So when we have a circle on the graph, the center point of that circle is going to be in this formula that we're using. It's going to be H comma K, X comma Y. That's just a point. It's a coordinate point. And all points on the circle x, y in the distance formula. So if we plug all this into the distance formula and we solve for r, basically, so r being the radius or r being the distance from the center point to the curve, here's the formula. Maybe simplified a little bit better, it looks like this. And this is the formula that we're going to use right here. Okay, the equation of the circle. All right, so let's jump back over here to my computer screen and we're going to do a couple of these right here. So there's the equation of the circle. So x minus h quantity squared plus y minus k quantity squared equals r squared. That's what we're going to use. HK is the center point and R is the radius. These are all very important things that you need to remember. All right, so let's go down here and let's look at the first question. This is example 1 in your books on page 229. All right, so here we are. Find the equation of the circle with the center 2, 0. So what is that? That's our H and our K. And the radius of 3. So what is that? That is our r equals 3. So let's just write some of those things down right here. So we'll write r equals 3. That's important. So our h is going to equal 2, and our k is going to equal 0. Okay? So important information that we'll need. And now what we want to do is we just want to plug it into our standard form of our circle. What is that? Let's go back up here. It's this one right here, equation of the circle, standard form. So we're just going to plug it in. So let's actually write that form up there, and then we'll just plug into it. So x minus h quantity squared, and that's going to be plus y minus k, and that is quantity squared as well, and that's going to equal r squared. All we want to do is plug in the information that we have to this. This is all they're asking us to do in this problem. So we're going to plug in our h right there. We're going to plug in our k right there. And we're going to plug in our r right there. And we're going to be done with this one. Okay. So here we go. We have x minus h. What is h? It's 2 quantity squared plus y minus k, which is 0 quantity squared, equals r squared, which is 3 squared. Now, what you'll do here is you'll simplify. You'll do what you can do, right? Anything that you can do to simplify this out, you will do that before you give me your final answer. What can I do here? Well, technically, I could FOIL that, but I'm not going to. I don't need to do anything there. So that's just going to be x minus 2 quantity squared plus this right here. What is anything minus 0? It's just itself. So we're just going to say y squared. We don't need to do anything there. We don't need to keep that looking like this. We can simplify that. And then that equals, we know what 3 squared is. 3 squared is 9. So there we go. This would be our answer for this problem. The formula for this circle, okay, with these qualifications right here, is going to be x minus 2 squared plus y squared equals 9. And that's going to give us on our graph, when we put that on our coordinate points, that is going to give us a circle on our graph. All right, next, example number 2 in your book. All right, so I've kind of put this on our graph paper and I've blown it up just a little bit so you can see it. What we're going to do is find the equation of the circle passing through 0, 0. Now, it doesn't say that the center is at 0, 0. It says that the circle passes through 0, 0. So that's happening right here. Let me kind of highlight this so you can see it. That's our 0, 0 point. And we could even write that on here if you want to. We'll put 0, 0 right there. Okay, so that's this point right here. Okay. And then what else does it say? It says that it's having the intercepts of 10, 0. So in other words, at 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right there. This point right here is at 10, 0. So that's one of its intercepts. What does that mean? It's crossing the X line there at 10, 0. The other intercept is at 0, negative 6. So 1, 2, 3, 4, 5, 6, negative 6. So it's right here, and that's going to be at 0, negative 6. Okay, so there's the 3 points that it gives us. All right, notice it does not give us a center point. Okay, does not give us a center point. So what we need to do is we need to figure out the center point. Okay, we can't figure out our formula without our center point. Why do we need the center point? Well, going back up here, what was our center point? Our center point right there is the h and the k. All right, so we need our h and our k to get our formula. So we're going to go ahead and we're going to find the center point. How are we going to find the center point? Well, what I would do is I would make a diameter. Okay, so I would connect my point here, my 0, negative 6 point, and I would connect that to my 10, 0 point. Now I have a diameter. What does that mean? It means if we can find the midpoint on this, okay, and you might be thinking, well, I'm just going to try to guess at, no, we're not guessing at the midpoint right here, okay? We're going to try to figure out the midpoint using our formula for midpoint. So let me kind of expand this back out. Let me get rid of this grid for a minute so you can see me kind of do the math work. And we're going to find the midpoint. Remember, that's the capital M. The small m would be slope. So midpoint formula, hopefully you remember what it is. If you don't, it's in your book. You can cheat just a little bit. It's x1 plus x2 over 2, comma, y1 plus y2 over 2. Okay, and that's going to give us our midpoint. So we're going to take our points right here, this one and this one, and we're going to plug into the midpoint formula. So let's call this one the x1 and the y1, right? We just have to assign one of them, and this is going to be the x2 and the y2, okay? So we just have to assign one of those. It doesn't matter which one you pick. It's going to be the same. So if you chose the other one, if you called this one the 1 points, it'll be fine. No big deal. So our x1 is going to be 10, and our x2 is going to be 0. So we're going to have 10 plus 0 over 2. 10 plus 0 is 10, so 10 divided by 2 is 5. So our first point is going to be 5, and then our second point is going to be y1, 0, plus y2, negative 6. That's going to be negative 6 over 2. Negative 6 over 2 is going to give us negative 3. So there's our 2 points right there. And what is this? This is our h and our k. Okay, there's our h. So let's write it over here. Our h is going to equal 5. Our k is going to equal negative 3. And our r is going to equal, we don't know yet. We don't know what the radius is yet. We'll figure that out here shortly. And maybe you already know it because you're really smart. But we'll figure it out in just a second. But let's go ahead and put our point here. And so our midpoint of this point in the middle, is going to be at what? 5, negative 3. So 5, comma, negative 3. And if you figure that out, you're going over 1, 2, 3, 4, 5. 1, 2, 3, there's going to be our point. If it was still on the graph paper, you would see that it is the middle of that line. So mathematically, we figured that one out. Now we need to figure out the r. What is the radius of this point? Well, the radius of this point is going to be our distance between these 2 points, right? What's the radius of the circle? The distance from the midpoint to the circle itself. So how are we going to find the r? How are we going to find the distance? Either way, you can go from here to the -6, 0, or the 0, -6 point over here, or you can go from the center point to the 10, 0 point. It doesn't matter which way you go, the distance is going to be the same. We need the distance formula. So we just used the midpoint formula, now we need the distance formula. So distance equals the square root of, do you remember this one? So this one is x2 minus x1, and that's going to be squared, and that's going to be plus the same thing with the y points, y2 minus y1 squared, okay? And again, what we're going to be using here is, don't forget, don't go back to the original, okay? We're not going back to these points over here. We're using the midpoint, and because we just want the radius this time. So our radius, let's call this one now, this is our x2 and our y2, right? So our x1 and y1 is going to be 10 and 0, and our x2 and y2 is going to be 5 and -3, because we're using the midpoint and one of the points. And you could use either one, doesn't matter which one that you use. All right, so go back here, and we're going to have that distance equals the square root of our x2, which is 5, minus 10, and that quantity will be squared. And we're going to add that to our y2, which is -3 minus 0, and that quantity will also be squared. So we're just going to go ahead and plug into that, and you'll see that it's all going to come out. And I'm doing it just a little bit different than the book is doing it, but it will all come out the same. All right, so what we want to do now is we want to go ahead and add these together, or combine these terms, however you want to say it, subtract them. So 5 minus 10 is going to be what? It's going to be -5, and we're going to square that, and that's going to give us 25, positive 25, because when you square negative, it becomes positive. Plus, what is 3 minus 0? It's 3, or -3, so it's going to be -3 squared. -3 squared is positive 9. So 25, this is still the square root of, this is still d equals, and so we're going to get d equals the square root of 34, okay? And that would be our answer. That is our distance. What is our distance in this case? Our distance is our radius. So this distance right here becomes square root of 34. So the distance here is the radius, square root of 34. Okay, those are the things that we needed. Now in your book, you can go ahead and turn the page to page 230. I'll show you that real quick. So here on page 230, now all we do is substitute back into that equation. All right, so let's do that real quick right here. We're going to have our equation is going to be our standard form for our circle, and that is going to look like x. And so what's our x? That one right here. So we're going to have x minus h, which is 5, and that's going to be squared. And then we're going to add that to parenthesis our y minus our -3. Minus minus, how does that work? That turns that positive 3 squared equals the square root of 34. And then don't forget that is everything is squared, like all of the pieces of this are squared. Basically, we're done. The only thing that we can really do here is we could cancel this out. So our final answer is going to be x minus 5 squared plus y plus 3 squared equals 34. And that would be our final answer right there. All right, hopefully you were able to follow that. It's not super complicated, I don't think. It's just a new formula to learn. The only thing there that you have to remember is to go back and remember, okay, what's my midpoint formula? What's my distance formula? If you can remember those, then I think that you can do the math there that's involved in getting those equations to work out. Okay, that's all I've got for you. Hope you have a good one. We'll see you later. Bye-bye.